Today we are going to see one more operation on a given matrix, that is the transpose of a matrix. So transpose of a given matrix can be done by interchanging the elements of a column by the elements of a row. So suppose I have a matrix A. I'm taking a 2 cross 2 matrix so that you can easily understand how transpose is happening. I'm taking the elements as A, B, C and D. This is of the order of 2 cross 2 or 2 by 2. Okay, now whenever we are doing or we are taking out the transpose of any matrix, we represent it as A and suffix we have T at the top. So now the transpose of a matrix is the interchanging of the elements placed in the first row by the first column. This is your first column, this is column number 1 and this is row number 1. Okay, so the you can say it is a displacement of the elements. Their location will get changed, or you can say the flipping of the elements across the main diagonal. This is the boundary region. This part will appear here and this part will appear here. So if we take out the transpose of this particular matrix, what we'll get to see? This is your first row AB. This row has to be converted into a column. So this AB which you are seeing in the horizontal portion should appear in the vertical portion. So your AB will be like this. Your elements will be placed to a new location, that is in the column number 1. And the second row, row number 2, has elements C and D. They will move to the column number 2. So here it will be C, here it will be D. This is your column number 2. Okay. So means A and C, they were lying in column number 1 in the original matrix. Now A and C, they are lying in the row number 1. In the original matrix, B and D, they were lying in the column number 2. Here B and D, they are lying in the row number 2. So this is the interconversion of the change in the location of the elements. Now transpose does not mean that you will change the elements totally. No. One thing, elements will not be changed. Elements remain same. Only the location is changed. And second thing is relocation is applied throughout. Relocation is applied throughout the matrix, not just one position, throughout the matrix. Means if you are touching a column or a row, you should not stop there. It should surpass, it should be applied throughout the matrix. Then only the transpose operation will be completely done. Now let's take an example. I have a matrix B which has elements 7, 8, 9, 1, 2, 3. Now this has got how many rows? It has got row number 1, it has got row number 2, and columns are how many? C1, C2 and C3. So order is expressed as number of rows by number of columns. So this is a 2 by 3 or 2 cross 3 matrix. This is the original matrix. Now you are asked to find the transpose of this given matrix. So now, how many rows are here? 2. And how many columns are here? 3. So when you will interchange them, the number of rows will become the number of columns, and the number of columns will become the number of rows. We'll see how it is going to happen. Now 7, 8, 9, this belongs to row number 1. This is the horizontal placement. Now when this horizontal placement gets converted into a vertical placement, it will be placed like this: 7, 8, 9. Correct? Now you see the second half of the matrix. This is your row number 2. It has got elements 1, 2 and 3. Now this horizontal position will again be converted to a vertical position. So now this one will be here, 2 here and 3 here. This is your transpose. So as I was saying earlier, that the number of rows in the original matrix, that is 2, will be what? Number of columns for the transposed matrix. You will get to see such thing. So here the number of rows was 2. Here number of rows has increased to 3. And the number of rows here was 2. Number of columns, if you see, this is C1, C2. So 2 and 2, that means the number of rows in the original matrix will be equal to the number of columns in the transposed matrix. So if this thing is satisfied, that means your transpose thing is done perfectly. There's no error in that. Let's take one more example. Let's take a matrix C, and it has got elements 1, 4, 10. I'm taking any random values. 2, 5, 20, 3, 6, 30. Now this is a 3 by 3 matrix. You have 3 rows and 3 columns. Now the transpose of this matrix will be this is your row 1, row 1, row 2, row 3. Similarly, you have C1, C2, C3. Now row 1 will become C1. So this 1, 4 and 10 will be like 1, 4 and 10. What I'm saying is row 1 will become C1. So in columns you have elements in the vertical direction. In rows you have elements placed in the horizontal direction. So the interchanging of rows and columns we are doing. So elements placed in the horizontal places will they will appear in the vertical ones. So 1, 4, 10 getting occupied at first column. Now second row 2, 5 and 20, they will be here 2, 5 and 20. And last one 3, 6 and 30, third row will become third column 3, 6 and 30. So this is your transpose of a given matrix. Now if you take out the transpose of any transposed matrix, you will always get the original matrix. Means this is the transposed matrix of this original matrix. This is the transposed one. Now if you again get the transpose of this obtained matrix, you will land on to the original matrix. If you want to see, you can see that I'm taking a smaller one. I'm taking a matrix Z as 1 0 0 1. I take the transpose of this matrix. This will be row 1. Row 1 will become C1. So this 1 0 1 0, and this is your row 2. It will become column 2. It will be 0 1. Now if you take the transpose of this transposed matrix, so this 1 0, row 1 row 2, this 1 0 is in the row 1, put it in the column place, 1 0, and then again 0 1 0 1. So this is how you will take out the transpose of a transposed matrix. Means this is the two times you will perform transpose operation on the matrix, and you will always land on to the original one. Let's take one more so that it is more clear. I'm taking a matrix X and I'm putting elements as A, E, G, H. So I'm taking the transpose of this matrix, that is XT. So this is your row 1, AE will become column 1. This GH, that is at the row 2 position, it will become column 2. So this will be GH. This is your transpose of the given X matrix. Now I am taking the transpose of the transposed matrix, means transpose of this matrix. So now this AG is at row 1. So it will become column 1. So it will be AG. EH is at row 2. It will become EH. So if you compare X transpose and the original matrix X, they are similar. They are identical. That means you have any matrix, taking out its transpose, then again taking out its transpose, that will give you the original matrix M. That's all for today now. In the next session, we'll see how addition of any two matrices is done. Stay tuned. Thank you.